Okay, thanks for joining. This is a lesson on prime and composite numbers, and it's coming from the pre-algebra book, and it's lesson or section 4.1. Okay, let's talk about prime and composite numbers. But first, that's the title of this section. But let's first of all talk about multiples. So obviously, this is pretty basic stuff. Let's take a look at the multiples of 2. So 2, 4, 6, 8, 10, 12, etc. The multiples of 2. The multiples of 3. 3, 6, 9, 12, 15, 18, etc. The multiples of 5. 5, 10, 15, 20, 25, etc. So these are basically multiples, are just the multiplication table that you learned, like in 4th grade. It says list the first 4 multiples of each of the numbers. And so, for instance, if you had -5, -5 times 1 is -5. -5 times 2 is -10. -5 times 3 is -15, etc. Okay, so one more. 4 times -5 is -20. Okay, so remember that a positive number times a negative number equals a negative number. Okay, so now we will find out if a number is a factor of another number. Okay, so we're talking about factors. A factor of an integer is an integer that divides the given integer with no remainder. Okay, so for instance, the factors of 12 are 1, 2, 3, 4, 6, and 12. So if we take any one of these 6 numbers and we divide it into 12, remember anything divided by 1 is itself, so clearly 1 goes into 12 exactly 12 times. 2 goes into 12 exactly 6 times. We're going to have a 0 remainder. 3 goes into 12 4 times. Again, 0 remainder. So basically, a factor of an integer, a factor of one of these integers. Remember, an integer is basically a positive or negative counting number. So -3 is an integer, -2 is an integer, -1, 0, 1, 2, 3, etc. These are all integers. So an integer is divisible by another integer. They're called factors. Okay? So for instance, if we were to list the factors of 24, it would be any number that goes into 24 evenly. Okay, so 1 goes into it, 2 goes into it because it's even, 3 goes into it, 4 goes into it, 5 does not, 6 does, 7 does not, 8 does, 9 does not, 10 does not, 11 does not, 12 does. And I think that's it. I guess you could list the number itself if you wanted to. And I think that's it. Remember, 4 times 6 is 24. 3 times 8 is 24. 2 times 12 is 24. And finally, 1 times 24 is 24. Okay, so this list of 8 numbers are the factors of 24. So let's take another number like 58. We want to list its factors. It's even because it ends in an 8. Remember, even numbers end in 0, 2, 4, 6, or 8. Right? So it's the last number that we're interested in. The last number is an 8, so this is an even number, so it's clearly divisible by 2. Okay, so if we took 2 into 58, we're going to get 2 goes into 5 twice, with a remainder of 1, bring down the 8, and 2 goes into 18 twice, so 2 times 29 equals 58. Okay, so the question is there any other factors of 58? So we know 58 is 2 times 29. In the next section, we're going to talk about prime numbers a little bit, but a number that can't be broken down any further is a prime number. So 2 is only divisible by 2 and 1, so it's prime. 29 does not appear on the multiplication table. There's no other numbers that go into 29 evenly, so it's also prime. So these two numbers are both prime. So 58 is only divisible by 2 and 29. You could try other numbers. You could try dividing it by 3. And 3 won't go in evenly because you're going to have a remainder of 1. So anytime you have a remainder, it doesn't work. So 3 and 19 are not factors of 58. Okay, so that is basically you just try different numbers. You want to start with to find the factors of a number. You just want to start with probably 2, 3, 4. Just kind of go through the list of the first 10 numbers or so, and see if they will go evenly into the number that's being asked. Okay, so for instance, there's a problem that says, is the first number a factor of the second number? So what we're going to do is just do division. So does 9 go into 217 evenly? Well, let's just do our division. So 2 times 9 is 18. Subtract 18 from 21, we get 3. Bring down the 7. And then you think of your multiplication tables. 4 times 9 is 36. Subtract 1. There's a remainder. That's your remainder. So this does not go in evenly because you have a remainder. Okay, so the answer is no. It is not a factor of, the first number is not a factor of the second number. Okay, on the second section, that was like number 14. If you look at the second section, list in order all the factors of a given number. So for instance, they give you like number 24 is 63. So 2 does not go into it, so we can skip over 2. 3 goes into it. 3 goes into 63 exactly 21 times. So 3 is a factor. 1 is a factor. 1 is always a factor. So then we move down the list, and 4 will not go into 63 because 2 won't go into it. It's not even. So 5 won't, because remember the multiples of 5 end in 5 and 0. 6 won't go into it. You can try 6, but it won't go into it. Let's try 7. If you think of your multiplication table, 7 times 9 equals 63. So 7 and 9 actually go into it. Okay, now 3 goes into 63 21 times, so we can put 21 also, because 21 goes into 63 as well. It goes in there 3 times. Remember, 21 times 3 is 63. 21 times 3 is 63. 7 times 9 is 63. And then finally, 1 times 63 is 63. So these are all the factors, and they're listed from least to greatest. Okay, so these are the factors of 63. All right. Well, I'm going to stop the video there. That's section 4.1. We do even problems. In this section, we're going to do 2 through 40. And I guess I will say one other thing. A prime number is a number that's only divisible by itself and 1. For instance, 7 is prime. 5 is also prime. 3 is prime. 2 is prime. 1 is not prime. 1 is neither. Examples of composite numbers are numbers that can be divided by another number. For example, 4 is 2 times 2, so it's composite. 6 is 3 times 2. 8 is 4 times 2. 9 is 3 times 3. So these are all examples of composite numbers. So typically they're usually prime or composite. If they can be broken down with a number that has factors other than itself and 1, then it is composite. Prime numbers are only divisible by themselves. So 7 is divisible by 7, but the factor is 1. So that's a prime number, as is 5, 3, 2. The next prime number after 7 would be 11. Okay, and this list continues on. All right, so we'll stop there. That answers questions 26 through 40.